Hi everyone, this is Mehul Mehta and welcome back to my YouTube channel. Today we have a very special guest. He is none other than Agus. So let me give you a quick background and quick introduction about Agus. So Agus is the founder of Modiva.ai. He guides a lot of AI startups. He is currently advisor at McKinsey. Also, was serving as a head of model risk at Wells Fargo, and he has like wide experience in the corporate. So today's podcast, it's all about learning from expert like Agus about quantitative finance, risk management, model validation, and AI. But first of all, really thank you, Agus, for joining in and giving me your time.
Thank you so much. Thank you. Thank you for having me.
Yeah.
Uh, uh, Really a pleasure to be here.
Sure. So Agus, like from where did it started? I know like you graduated with an engineering degree. So like how did you transition to quant finance, or like can you tell like what's your story?
Yeah, this is an interesting journey, and this is probably good for a student who really now studying and about to graduate and all of those things. So I did my PhD in the early 90s, and I got my PhD in the mid 90s. And my PhD dissertation and my research at that time is neural networks. So the early day of neural networks. So I did signal processing, I did pattern recognition, and all of those stuff, right? And also did a lot of statistical stuff. Uh, so when I graduated with the machine learning dissertation in machine learning, think about it. This is 30 years ago. No job as machine learning engineer, no job as data scientist, whether you're a statistician, you're an econometrician, or you're not. And I was from engineering, so I have no career path for me to be in the what we call today data science or quant finance or whatever. It's no such thing, in when I graduated at that time. Uh, so I took the traditional route. I'm an engineer, so I work as an engineer. So I spent since my graduate school day, I was doing part time, did as a research assistant at Ford Motor Company. So Ford paid on my education basically, right? So I joined Ford after I graduated. Many of you, this probably resonate to many of you, uh, international student, because I was an international student at that time, right? I have no H-1B visa. Yeah. I have no green card. And Detroit, big company, they're not hiring people without green card, right? So I have to join a very small company as a contractor and place at Ford Motor Company. So I hired through agency. So I have to go through that when I graduated, even though I was an intern at Ford for as I did co-op at Ford many years. They still didn't hire me. Okay, so but I have to go through the route as international student. Nowadays, many company is more open-minded. Nowadays, a lot of companies sponsoring visa, right? Sponsoring H-1B, sponsoring your green card application. My time was not. Okay, so it was very hard, but I went through that. Then when I finally get my green card, at that time it was fast because I came from Indonesia, and the no line, right? So it's one before 10 months I got my green card, luckily at that time. Therefore hire me as a as their direct employee, right? In engineering organization, because no job in machine learning. So I did engineering. I work as a reliability engineer, and I work as a quality engineer, reliability engineer, and then I work at the beginning also in many different engineering assignments. I designed wire harness for car. I went to become in the powertrain division. I designed engine, right? So I became when I left Ford in late 2003. I was one of the engine design manager, very few, engine design manager. So I was one of the engine design manager at that time when I left and I went to banking. So that's what I was called by Bank of America at that time, out of the blue. Well, it's not out of the blue. Somebody that used to work for me or did go up together and work for me. He's a statistician. He's a PhD statistics from University of Michigan. He was employed by Bank of America, and he talked to his boss, so they called me. So I joined Bank of America, right? And he worked for me. I became his boss when I joined, right? So that's the and transition from engineering to banking is very hard because I know nothing about banking, and I entered banking as a very senior guy, so it's hard, but I made it, right? So that was into January 2004 when I joined Bank of America. So here we go, and then the rest is history. I spent the rest of my career in banking. So that's the situation. And then when I joined Bank of America, I did not go to quant finance directly. Okay, they hired me as head of uh, process reengineering, as the head of quality and productivity to do process engineering. And at that time, I worked on many different projects. My team worked on many different projects, and I was I was the head of quality and productivity for risk management organization at Bank of America, right? So I didn't enter from confidence when I joined, and then I get involved. But my love, I always very passionate about modeling. Okay, yes, we do at that time quality productivity. We do statistical stuff, but it's a very really toy statistical techniques, right? A lot of more process management. But one of the project at that time that involved we have to fix anti-money laundering problem at Bank of America, the early day of anti-money laundering. That's when I get involved in the anti-money laundering and working on anti-money laundering. Then I'm working on credit process as well. So I work on the credit side as and in that area. So then after leading that group for 18 months, the head of enterprise credit risk, and market risk asked me, "Hey, I think we want to create quantitative risk group. I think you should lead it." Yeah. So then we built a quantitative risk group from the ground up.
Wow.
Okay, hiring people and all of those things, learning the craft, hiring a bunch of people. So I like quantitative risk. We're thinking about, hey, we're going to manage risk management differently. We're going to be more strategic. So we're going to do approaching modeling differently to manage this. In particular, in the consumer side, consumer banking, we're going to approach it differently. So that's how I do. And I would say this one. Banking is probably among an area that the easiest to learn. It's
Mm.
very different than learning engineering and biology or health science and all those things. You cannot pick graduate school book,
Yeah.
read it without understanding from the beginning on the math. So you have to take 200 level class, 300, 400, 500, 600 before reading 700 level book, right? So in engineering and many disciplines is like that. But in finance, 700 level book, just read it. You'll understand it,
Right,
right?
right,
It's so
right.
easy to learn. It's
So,
probably among the easiest subject to learn in
okay.
my opinion. Yeah. So I would say, learning the banking side, the finance side, that's is not very essential. Okay, you can learn it as you go very very quickly. Learning the fundamental
Mm-hmm.
knowledge that is transferable.
Right.
That's the most important thing. So learning the foundation, something that long lasting. So think about it. The linear algebra.
Right.
Linear algebra from 40 years ago is still the same as linear algebra today.
Right.
very long lasting. We can use it, right? Learning calculus from 40 years ago and calculus today is still the same. So learning fundamental that is very, very long lasting. Don't learn tool.
Right.
Tool is thing that change a lot.
Mm-hmm.
But for foundation, you learn foundational stuff that make you long lasting. So that's what I do. Learn the foundational stuff. And then depending on where the problem is, you can learn very, very quickly.
Right. So, August, I picked few things which, I'll try to summarize. First is in 1990, you were doing PhD in neural networks, which is
Yes.
like, like people, I mean, it is insane because back then, they were not like computers were not that great, and still, working on such complex project, and not just
Yes.
working, you did a PhD in that, so that is like phenomenal. Second thing that I loved about your story is even though you were working in engineering, right? And a lot of people have this, they feel restricted that, oh, I have spent several years in a field, might not, or let's say I should not move to a different field.
Yeah. Yeah. That is very, very important. That's very important point. What we do in school is learning to learn.
Yeah.
Yes, learning to learn. So think about it. If you think about, I did neural network, and if the biggest conference today in neural network is NeurIPS, right? That's the biggest conference. In my time, it's called NIPS.
Okay.
Okay, so if you look at NIPS 97, that you can Google this. Okay, Google my name, NIPS 97. Okay, I was there presenting autoencoder in 97.
Wow.
Okay, in the same session is there a lot of big names in that room, including
Mm,
including
okay.
Jeff Hinton, yeah, including the godfather of neural network. It was in that room. That was like a year after I got a year or 2 year after I finished my PhD, right? So yeah, I learned that subject, but the world not ready for that. And also at that time, you learn the foundation of neural network, right? You gradient descent is still gradient descent. It's still the same thing. Back propagation, still back propagation. It's the same thing. That's what the autoencoder, still autoencoder back then, and autoencoder today, still the same thing.
Mm.
So the foundation out there. And at that time, by the way, I have to code from scratch. There's no PyTorch, right?
Yeah.
Yeah, no scikit-learn, no Python. So I have to code everything from scratch in C++,
Wow.
right? And by the way, it ran in 286 computer. Yeah, Intel 286, not even Pentium. Okay, so that's the type of thing. But you learn the foundation, you learn the math, you learn the algorithms, right?
Right.
Now today is a lot more scaling, a lot more engineering. I would say the progress. I'm not discounting all the progress, but a lot of things are engineering,
Mm.
trick,
Right.
not foundational.
Right.
Yeah, engineering trick is important to make it work, but it's not foundational,
Mm.
right? The math is foundational. Everything trick, okay, patch normalization and all of those things. It's just engineering trick to make things work.
Yes. Yes.
Yeah. And those are not foundational. And those things change,
Mm.
right? So that's you need to make the differentiation. But willingness to change in the school, you learn to learn.
Right.
And then if the work at that time, I have to design car engine. I design car engine. I change. I have to switch my research at that time because when I was working, I still enjoy research, right? So I say, okay, I have to now switch from machine learning into how to design engine better. So I did more design optimization, this optimization under uncertainty, and all of those things, right? So it's more statistics, more operation research, more optimizations that I do, right? So I made and I even wrote a book, and I published a book back in 2000, early 2000, in design of experiment, in computer experiments. Nothing to do with my PhD. So I switched and I published. I used to publish in IEEE and Neural Network Journal when I was a PhD student, right? When I left after that, I published in ASME, Society of Mechanical Engineering Journal. Okay, I published in Statistical Journal and Mechanical Engineering Journal. That's what I published.
And
Completely different.
And this is the best thing I like about you, Agus, that being an international student, you came to the States, and it's so hard to, create your own image because, there are so many people. And this is just for the viewers. Agus is very famous in the US. Also, a lot of startups in the United States take advice from Agus. Not just that, he also he his own company Modiva.ai. If you go look at the company, Agus has basically told how to interpret different machine learning algorithms, because a lot of people say machine learning are black box. But at the website, if you read the website, Modiva.ai, Agus has actually broken down each and every step. So definitely, just stay in here. I have a lot of exciting questions. Agus, like, one
This
more
is this
question.
is one thing that's important for student and also people in the early career as well. Because say, hey, I want to work on an area that I can excel, that I have benefit because I have access to the real thing. So
Right.
if you think about it, when I was a engineer at the time and at Ford Motor Company, my research switched into engineering design because I can do things in my daily life. I have all the resources and knowledge that more than anybody else. So when I was in banking, so back to the machine learning, the in 2014, I was back to the US in 2013 after 3 years in UK, right? 2013, when I started become the head of model risk for Wells Fargo. 2013, I look at it, machine learning start coming back again. What's going on here? What's new, right? So I left the area for quite some time. Yeah, I do many different things, but then okay, this is coming back again. So I look at it. Okay, this still same old, same old. Okay, gradient boosting, still gradient boosting, and the it's just okay. No longer support factor machine, no longer popular because my time I left neural network because the field gets supplanted by support vector machine and gradient boosting machine. So if you remember in the early 2000, neural network dead. Nobody want to touch neural network. You want to do research in neural network? Dead. Everybody work on support factor machine and gradient boosting machine. I switch. I work on different things, but 2014 start coming back, and then you look at banking. Okay, this is the banking side. What do we need in the banking? This is very different industry. This is very regulated. People start talking about explainability and things. So I work on explainability because that's what the around you is needed. So I don't work in computer vision because I don't work in computer vision. I don't want to be somebody else. So this is for many of you that in the early career, the opportunity are around you. Look at what are the opportunity around you because if that's something that around you, you have access to the knowledge, you have access to the data, you have access to the experience. Don't try to do something else that's not around you because around you so many things that's not being solved yet, right? And you can contribute. So I chose to do interpretable machine learning at that time because this is what we need. So then we build it, we do all kind of things, we put it in real world, so we know from firsthand what work and what don't work. Then I was in the part of the model. I manage model validation team too. So okay, how do we break model? How do we hack model? How do we make sure that no surprise model are safe when we deploy a reliable model? Do research on that subject. Improve your knowledge in that subject. Be expert in the subject that is around you. Don't try to be somebody else.
Yeah.
So that is very important for many of you that early in the career. Take
Right.
advantage what around you and go deeper because you can be expert better than anybody else.
Right. Also, Eagles, like, like a lot of times, students are just confused. how to break into quantitative finance,
Mm.
because like at least let me tell you about India. India as a country, I mean, the quant finance space is very niche. It's still growing, and it is at a very nascent stage.
Mm.
So like what would you recommend students, what
Yeah,
subjects to read? Can
yeah. You A few things that you can do. Of course, networking is very important. Yeah,
you?
getting to know. Nowadays, you have LinkedIn. Reach out people. Find mentors. You can reach out people. My time it was very difficult because no internet. Okay, the early day of internet, right? Yeah. So nowadays, you don't be afraid to reach out to people
Mhm.
and get mentorship and understand it and what's the opportunity that you can do in that area. But when we talk about quantitative field, also don't be narrow-minded, be very broad, right? If you think about my career, I never what's the opportunity, I grab any opportunity that's available at that time. It's a process engineering, well, quality engineering. When I look back, it's very boring field, but it gave me a way
Right.
to be closer. And then I'm going there, and then I work on money laundering. So getting closer. And then I work on credit, getting closer, and then work on the capital market. Now I'm getting closer. Yeah. So looking at opportunity because you never know. If you ask me, have I ever been thinking to be the head of the most senior quant at Wells Fargo? Not in my life.
Okay.
Yeah, I was machine learning, PhD machine learning. Nobody wants me. Yeah, I did design engineering because of that. Yeah, and then somebody gave me opportunity to become the head of quantitative risk. So you just have to prepare yourself. And my first experience as a manager,
Mhm.
I was a manager and never a first line manager. I right away jump into manager or manager on the engine design. Not an engine guy at that time. I don't have mechanical engineering degree at that time. I am the only one in the entire building, non-ME. Yeah, in the entire few thousand people that all ME, I am the only non-ME. So how? So I prepare myself to be ready. One day I get called, right? So I work as individual contributor, technical specialist on how to design things better. Okay, my field is design. Okay, how to design things better. Moving from machine learning guy into design guy, how to design things better. And I influence people to learn to use my methodology. I wrote a lot of code and I teach people, help people work with a lot of engineers to make their design better and teach them. And one day I get call from the chief engineer of engine engineering. Call me and say, Agus, come to my office. I came to the office. We have team here at the corner. We have 80 PhD that working on the computational fluid dynamic, on the finite element, on the dynamics, all the complicated stuff. Why don't you manage it? I said, John. First of all, John, I never manage anybody. I am individual contributor. I'm a technical specialist. Yeah. And two, I know nothing about engine. Oh, you know this thing. You've been working with my engineer. You work with them. You make my design better. You taught them. A lot of people follow you. A lot of people follow your lead, working with you, and all of those. Okay, I was put in there. I was. Oh, I prepare myself. People respect me in the building. A lot of people knows me. So one of the manager that report to me at that time, one of the manager that report to me was my manager when I was interned as the first year graduate student. Yeah. And a few years later, I'm his manager. Think about that, right? He's a specialist in NVH, noise vibration harness. Incredible guy, right? And then I manage it. So how? So what I'm trying to say is, in your area, you look at the opportunity, you develop your expertise, and with thinking about how can I go there slowly, right? I at that time I do the design methodology. So I never have ideas that they give me place to design it, to manage these people that I used to help them, support them, help them. Now I suddenly, okay, this is your people,
Mm.
right? And then when I left, I was the one. We designed a brand new engine for Ford Motor Company. When the engine came out, the top 10 best engine, the best engine ever, is in the article even today. 3.5 liter V6 engine that is Ford and 150 is the most reliable engine ever that Ford Motor Company produced. I was working in that one with my team, right? So opportunity will come, but you prepare yourself. So when I was the head of quant, to most senior quant, well, I went through a different role, and okay, they put me into this, but I'm ready because I've been working with these people and I know the math. It's not hard. You just learn application. The math is the math. So I did that. Then after doing that through the financial crisis, to all of those things, and 7 years later, somebody called me from UK. Hey, we need the director of analytics for the entire risk management and for the enterprise. You call me, you get interview, I jump, right? And it's very broad, all kind of modeling techniques, all kind of applications. Some of them I never touched, right? But you can learn. You have confidence that you can learn it.
Mm.
But you prepare yourself to be ready on the technical side to be ready. So that's important. And then uh, one day, Wells Fargo called me. We need the head of model risk. I never done model risk, okay, but I know I can do it. Right? You have some idea. I can create it. In fact, how can I create this into a new discipline of model race? So the job that is most rewarding for me all the time is when something that you create your job, you redefine the role. Remember when I did my early career, I do design methodology, robust design, design under uncertainty. Such thing as that job. That's my early career. And then I became technical specialist in that area. So every job that I have, I'm working on how can we change it. So you prepare yourself. When the opportunity come to you, you grab it because you're ready. Prepare yourself. So that's in terms of career in quant finance. So what's available? Look at very broad here. You have the consumer bank is very different, wholesale bank is very different, trading is very different, insurance is very different, right? So quantitative field is very broad, and grab the opportunity going there and then thinking about find a way how to get closer and closer, because once you're in, you build network, you
Mm.
learn, right? Build your expertise and learn. Let's say, okay, I'm entering in model development in certain area. Yeah, I can move. I'm networking. I can move to learn to different area and slowly moving to the area that you're interested in. I can give you an example. I'm not going to name a name, but somebody that I hired many years back, and he's now with different institution. And we he came interview fresh graduate. I really like the person, but the rest of the interviewer no. Okay, so he didn't get picked into credit risk. That's what he wants because his background was statistics, PhD of statistics. He didn't get it. But the operational risk people took him.
Mm.
Okay. Operational risk people took him. So it became an work in the operational risk, right? And then say, okay, then he moved to credit. And then, well, it's not only moved to credit, then he moved to market risk. Okay. Then he moved to trading.
Mm.
Yeah. So you never know where you enter. Never, don't be too idealistic because your view as a student or early career probably very narrow like this.
Yeah.
Yeah, because you're not standing on top of the hill that see things very broadly.
Right.
So you're in here. And then how can I move? Because you can build your network. right? So this guy from the most boring area of operational risk modeling, no offense for people that do operational risk modeling, okay? It's just for me, it's a little bit boring. Now that move to a different group. We was I'm not going to name name, but I co-authored paper with him long time ago in a generative adversarial network. Okay, so yeah, so you never know, and you prepare yourself and go to a certain field, very broad. Go there and move around.
Right. And also, it was like what programming tool someone should start with, because we have Python, we have C++, we have SAS, MATLAB, RStudio. There's
Yeah.
so many,
It,
language.
it, 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 it doesn't matter. Okay, programming is a tool, not foundational.
Yeah.
It's a tool. Tool change.
Right.
Yeah, tool change. And this is talking about programming. When I did undergraduate in Indonesia. My early day, my freshman year, no PC, right? You came with IP, Honeywell mainframe is very using punch card and all of those things. That's my early day, right? Then PC in the third year of my college, PC start propping up at that time. Well, then you start having a different kind of class. Suddenly it has Pascal, Turbo Pascal. I learned it. And not only I learned it, I teach Turbo Pascal. Okay, because at that time, information system school or computer school start propping up. They have no teacher. So a side job, I teach. Okay, you want to do Pascal? I teach Pascal. Okay, even though I at that time, I don't know Pascal. I learned Fortran at that time. Okay, somebody need to do Pascal. Teach Pascal. Okay, I'm a physics student. I don't care. I teach Pascal. Data structure, I'll teach data structure. I'll teach you data structure. And then C came. Okay, so learn about C. And then artificial intelligence that coming up at that time, the early day of expert system Prolog. Okay, what to do programming in Prolog? I'll teach you programming in Prolog. So programming changes all the time. But you learn some of the basic structure, learn the pattern, right? Learn object-oriented modeling, learn functional programming, object-oriented programming, and all this stuff. And then language can change. So I learned programming in Python in one weekend, right? So I decided, okay, I need to code in Python. One weekend, I code in Python, right? Because you know object-oriented programming, programming, and you say, okay, well, this is very easy. It actually is very sloppy language that I can use and I can learn very easily. So yeah, programming language is something that you learn. You have to learn Java, learn Java. It's not hard. Learn programming language is not hard at all, in my view.
Also, like from your experience, what are certain certain projects wherein machine learning was used a lot? Because I know like you are being uh,
Mhm.
heavily invested in machine learning. So can you give us like few examples wherein you see a lot of machine learning getting picked up in the banking side? Or maybe just where you see a lot of machine learning being used in the
Yeah,
corporate.
sure, sure. Uh, Financial industry, banking, and all of those things, their interest is always predictive.
Mm-hmm.
And I classify broadly classification and all those things. I call it predictive too. Okay, it's anything that dealing with predictive and somewhat different from health or bioscience or health. Bioscience or health, they want to make inference. What is really the causal stuff? What is the inference, right? So they do a lot of statistics because of that, have statistical testing and all those things because they want to do inference. Finance don't do much inference or even almost none. What they care about is decision and prediction or decision. If it's prediction or decision, that's the domain of machine learning. Yeah. So any prediction and decision is the domain of machine learning. So that's what I said. When in if that's your interest, not about inference. Inference on making which variable are important. Is this a causal doing treatment, then you care about causality. There is some a little bit of that in banking, but mostly not about that. Mostly it's about decision, mostly about prediction and decision. Then it's the whole thing is machine learning. You can do that. Anything that. So do you do statistical techniques? Of course, you can do statistical technique, traditional statistical techniques. But why? Because you're not trying to make inference.
Mhm.
Okay, you're not testing hypothesis. Okay, you are predicting. You are making decision. So if you do logistic regression, you do logistic regression for the purpose of prediction or classification, right? For decision, not for the purpose of is this variable are significant or not. That's not what we care about. Okay, yeah. So we are not trying to understand behavior from data. Okay, we are not trying to explain data. We are trying to use data to make decision.
Mm.
We're using data to make prediction. We're using data to make decision. We are not trying to figure out what the data tell you.
Right, right.
Yes, it's very different. If we want to know from the data observation, what does this tell you? I'm going to make try to create the picture of the wall.
Yeah.
Then that's the domain of statistics, right?
Right.
But if it's about decision, it's about prediction, that's the domain of machine learning,
Okay.
right?
Also, is it easy to explain all this because banking somewhat I mean banking is regulated, like regulators do keep a watch on banking, all banking industries. So
Yeah.
like, was there a time when you use certain machine learning model, and I mean the regulators, or they were little skeptical, or they were little, like, I mean, because the bank is using on.
Sure, but is that is a thing of the past. If it's we talking about tabular data, it's thing of the past. Okay, because we can build very sophisticated machine learning that is inherently interpretable. And visit Modiva website because I can build very sophisticated mixture of expert. Okay, act combination. I can control gradient boosting machine to be interpretable. Read how to do it in Modiva. Okay, through functional ANOVA structure. You constrain the model, you can make it inherently interpretable.
Mhm.
Okay, so no excuse of building gradient boosting machine that black box in finance, because you can, if that's not enough, I can build mixture of expert. Read in Modiva as well. Mixture of expert, mixture of gradient boosting machine. That's even more of that. Okay, mixture of expert is more, it's a mixture of expert of inherently interpretable model is still inherently interpretable model. So
Mhm.
you can do that. You do neural network. Well, I can structure it to be interpretable. I created these techniques before, like Caminet. That's one of them, and then I put also neural tree. So visit Modiva to look at neural tree, very sophisticated neural networks that is inherently interpretable.
Also, something.
So you can do that. And now language model is very different. Okay, language model inherently you look at it, the model is not interpretable. Now, how can we make it interpretable? Right? We can. The answer is we can. Are we trying to do a lot of people, including anthropics, work on mechanistic in interpretability? I think is a dead end in my opinion. Okay, because it's too complex. So mechanistic interpretability is not going to work. Uh, we can approach it differently to make it interpretable. For example, I'm going to drop a clue here. For example, uh, LLM, you rely on LLM, it will vibe. And you have no control. So we have to control it. So how do we control it and make it interpretable? I control it with knowledge graph.
Mm.
Okay. I control it with knowledge graph. Knowledge graph is very interpretable.
Yep.
Yeah. The decision that made by knowledge graph is very interpretable because you know the entity relationship and you know the rule. Now you put that with LLM. You have neurosymbolic that is interpretable through knowledge graph. So
Mm.
the answer is yes, you can. To make sure your decision, when you make a certain decision using a language model, how can you explain it? Well, I cannot just ask language model to explain it. Language model will vibe and give you explanation that has nothing to do with the decision. So you can read the anthropic paper on this one, right? So it's nothing to do with that. So that's not explainability. But explainability is you tell a language model to follow a certain rule, and that is grounded using knowledge graph. Then you have something that's very interpretable. The decision, the step is very interpretable because you're directing language model using knowledge graph. So yes, you can make it interpretable. So it's, if you're thinking hard, thinking really understand, you really understand the foundation, the principle of interpretability, you can build this one. And if you can build it and you can explain it, the regulator will not stop you. The
Right.
regulator stop you if you don't know what you're doing. Yeah, the regulator stop you if you don't know what you're doing, and because you don't know what you're doing, you don't know the risk. Of course, regulator will stop you. But if you really understand it, my experience, I never get stopped. Yeah, we do correct decision with machine learning. But my machine learning is very interpretable. I put the interpretable gradient, interpretable XGBoost,
Mm.
right? I put Caminat. I put neural tree. That's something that you can learn from Modiva. So
Mm.
when you know what you're doing,
Right.
the computer will not stop you.
Mhm.
So when people making excuse about regulatory problem and things like that, because those people, they don't know what they're doing.
Mhm. Okay.
Yeah, if they know what they're doing, I, I deal with a lot of regulator, and you can explain it, you understand truly, they support you.
Mm.
Yeah. So
Right.
it's really about that. Do you know what you're doing? I'm not just a code monkey, just using somebody else's library and do it. Then you're in trouble.
Mm.
Right? Don't just be a code monkey. I really understand the foundation. I can explain it. This
Mhm.
is how things, I know what this can do and cannot do. Explain it. Then, yeah, you lead the way.
Right.
So
Also,
that's my approach. And if anybody need help on this, happy to help on the interpretable machine learning, be
yeah.
it on the generative AI or on the tabular data.
Yeah.
Okay, generative AI, it has to be combined to do a neurosymbolic to do it with the knowledge graph. Okay, so if it's tabular data, then learn from what is in Modiva.
Right. And Dr. Eagles, also like was there any time when an model predicted something, but it was like a bad prediction or model did not work the way it has to? Was there any case in particular?
That's all the time. All the time. For every model that you build, I can find in what situation your model not working. Okay.
Mm.
That's what the tool that's in Modiva, finding model weakness automatically. Okay. Any model that you build. Okay. I can find things that the situation where your model not working all the time. Okay. So this is the chronic problem in modeling. Ask any experienced quant, ask any experienced data scientist in banking. They must be humble to recognize that model works when the business don't need them, okay? And model don't work when the business really need them,
Mm.
okay? In a good time period, okay? When employment is very good, everything is good. Credit model, who needs credit model? Just approve everybody. Okay? We don't need the model. Okay? In a regular time, you want to do prediction, you want to forecast of credit loss. Who need model? Just look at 3 months ago, the last 3 months. It will be the same.
Yep.
Okay?
And
So
yeah.
so in well, the model works when the business don't need them. Now, in a different environment, changing environment. Suddenly your model don't work. That's the time when the business really need the model, need guidance here. I need the model. Okay, some of you work on the capital market side. Okay, regular time model work. The business don't need the model. Just look at the quote price quote. Okay, yeah, it's the price right there.
Mm.
So why do we need the model? I don't. Okay, and then a changing in environment when volatility change and all these things, suddenly your model doesn't work.
I,
That's
I'm
the time when we need model to price, and
I'm
the price is not working.
yeah, I'm just curious, Dr. Agus, have you ever utilized machine learning or any neural networks for volatility modeling?
I I read the with the one guy that used to work for me. His name is Bernard Haynes. So you probably can look into some of the publication of his. So when he was in my team, we published a lot of stuff in that. We work also on more the physics informed neural network, right? Because you have the stochastics. You have the PDE, right? You have the PDE, and then you convert it into backward stochastics differential equation, then you solve it with neural network. So use neural network to solve as a solver, right? So we do that a lot. Instead, okay, I'm going to do finite difference. I'm going to do that. You can solve it using neural network too. This is what all behind physics informed neural networks, right? Basically, you have the equation, then I formulate it into typically formulate the backward stochastic differential equation or something. You formulate it into that, and then you solve it. So you use neural network computational graph as a solver, basically, to solve the solution. The answer is yes. Okay, you can do many different things, but it's you can make it very more foundational instead of just neural network as curve fitting especially in computational finance in trading because you have the assumption of stochastics processes that you're going to use something that people agree that and we're going to use the stochastics using the PDE, then you can solve it, you can implement it, you can solve it using neural network. So I have a few publications on that, and but Bernard is the expert. So you want to look at Bernard Hines. He has several publications in that. He when I was at Wells Fargo. Okay,
Okay, but it can be utilized, right?
so just like sulfur,
Solve what?
yeah. You implement it. At that time I worked quite a bit on this. Implement it as the backward stochastic differential equation. Then you deploy this computational graph and then solve it using backpropagation, right? So put the boundary condition and all of those things, right? Then you solve it. So yes, the answer is yes, but it's just okay. Instead of using Monte Carlo, or instead of using finite difference, or instead of using, I'll use neural networks to solve it. Okay, so basically, from the equation that you have, you formulate it, you put boundary condition, and then use neural network as solver. So Bernard wrote a bunch of paper on this subject. Okay, you can search it in either in SSRN or in archive.
Perfect.
Okay.
Okay. Also, Dr. Eggers, like you have led like the model risk functions of like the largest US banks. So what are some key challenges you face by validating machine learning models? Like,
Yeah, I think this is the thing that's very important in model validation. This is the chronic problem in model validation. Yeah. If I talk about problem, it's problem about the approach. I'm going to look at more fundamental problem. A lot of people do a lot of testing, right? Statistical testing and all of those things. Now, what important is model validation. This is very key, very foundational. Yeah, we need to think about. It's not about statistical tests, and machine learning is the worst. We'll talk about this a little bit. What's wrong with machine learning model validation? We need to think about what is the intent of the use of this model, right? And then with the intent of the use of the model, how this model going to fail? So when I do validation, I call it model hacking. I am going to hack the model. I am going to find a situation where model will fail. So a lot of problem with machine learning, people that do machine learning, and this is the worst. The problem is also because the school only teach this. They teach building machine learning and measure the performance and machine learning using aggregate measure,
Yes.
using AUC, using MSC, using all those things. Okay. And then you compare, you test the MSE, and that's not model validation. Model validation is going to look at in what situation your model will fail. So
And
the challenge
how
is
to
that
identify, like how to identify like when model, like when we, is it by stress testing the model?
one of them, but even without stress testing, do you know which region? If let's say we talk about AUC, okay, or talking about MSC, I built model, the AUC is 0.75, let's say. It's 4.8, very decent, very good model, point AUC 0.8. Do you know that that 0.8 is average, right? The entire thing. So do you know which region that your AUC is worse than random, below zero point 0.5? Because if you have AUC zero point 0.8, you may have a region that AUC is 0.95, but you also have a region that your AUC might be zero point 0.3.
Mm,
It's failure. Zero point 0.3 is catastrophic failure because it's worse than random.
right.
Do you know? And you know why? And what variable? In what region? What range of which range of variable? That's the problem. So that's what you need to find because that's when you fail, right? Because if you build fraud model with AUC zero point 0.8, you have region that the AUC is zero point 0.3, for example, and zero point 0.3 is actually in the zero point 0.3 that is misdetection. Then you're in trouble. You lose a lot of money,
Mm,
right? So try to understand that. Instead of looking at people do, okay, I'm going to look at the better performance. I'm going to do fine tune. I run AutoML and I'm comparing like Kaggle style. Okay. Kaggle style comparing AUC. That's a completely useless thing. Very useless.
so
Yeah.
what metrics do you think are good for any, let's say, credit risk model?
The metric is fine. Credit risk model, we do it for main purpose of credit risk model is to rank order.
Right.
Okay. If you want to rank order, you can use any metrics of rank order, AUC, Gini, KS, all of those rank ordering metrics, right? So you need to do that, the rank ordering. But the most important thing is, do you know which region that your wrong rank ordering is wrong?
Mm,
Okay. Because that's when you're going to lose money.
right.
Okay. So yeah, I have AUC rank ordering zero point 0.8, but you have region that your rank ordering is completely wrong.
Mm,
Okay, so that's one. Okay, rank ordering is one. Of course, you have to do probability calibration because decisions for cutoff depend on probability of default, right? So you cannot just look rank ordering, but we also need to do probability because downstream decision in the business will be based on probability. But rank ordering, don't just look at rank ordering. Look at in which area that my rank ordering will be wrong. So this is why looking at the business, what is the purpose of the business? Well, the purpose of the business is to rank order to differentiate customer. Okay. Then in what situation I will fail
right.
to differentiate
That's what
customer
they're,
properly.
yeah.
Yeah. So that's important not only for model validation, it's important for model developer because you don't want to give model to the business and the model owner that they will get surprised later.
I agree.
You need to tell them upfront because you have, okay, in this region here, the model has high uncertainty. In this region here, the decision may not be good. Okay, but the business will say, even though it's not very good, I am going still to originate because I can charge high interest rate. I
Right.
can make money.
Right.
Yes, that's okay. I can still make money because I charge high interest rate.
Mm,
Okay. Or the business say, okay, I'm not going to originate this one. So the model is still good. It's not supposed to be fail of validation because as long as the business say we're not going to do this, we know how to manage the risk. When we talk about model, it's not about nitpicking, getting perfect model. No, every model are useful. If the model is useful, go. And the one that's not useful, then we're not going to use the part that's not useful. But
Right.
the part that's useful, we're going to use it.
Mm. Okay.
Right? So a lot of pricing model in capital market is like that. That is idealization of real world, right? Is you have Heston model, you have all kind of model. And do you think the world is like that? No, but it's useful to do the business, right?
Yeah.
So all those differential equations, stochastic differential equation, do you think the world like that? No, completely not. Even when I was an engineer, we have physics, right? The real physics in engineering. We say, yeah, the physics say that, but that's idealization. In real world, it's very different. The detail of real world is very different because my physics is 1D and I have to deal with 3D and different environment. So yeah, we say the physics is there, right? The physics is useful. Okay. But I don't trust the whole thing. All the pricing model in capital market is like that too,
Okay.
right? They are still useful. So if useful, we use it in the region that is useful,
Right. Right.
right?
So yeah, Dr. Agus, I agree. I agree. So Dr. Agus, these were like some bunch of questions which I, thought of asking you. One last question is any advice for students who want to transition to quant finance? Any advice you want to share with them?
Now, I think it's a couple of things. If you look at my LinkedIn tag, my LinkedIn title, yeah,
It says a
a
geek.
geek who can speak.
Yeah.
That's what I am trying to tell all the young people. You need to be a geek, meaning you need to be technically strong and grounded. Technically strong. You have to be a geek,
Mm.
but you have to be able to speak. You
Right.
have to be able to influence people. So how can you build that you are building your geek becoming deeper and deeper technically? Because I'm 60 years old. I retired from Wells Fargo. I'm still writing paper. So you can check my age index if you want to. Okay, go to Google Scholar, check my age index because I'm still working on writing paper and today I'm still writing code and all of this stuff. A geek. But to be able to speak, okay,
Mm.
for the people in India, think about you have to be able to be a snake charmer. Okay? You charm people,
Yeah.
convince people, even snake. Yeah? You have to be able to speak. You have to be able to listen to people, influence people. If you do job interview, the job is not for you to tell all kind of knowledge, all things what you know. Your job is to energize the people who interview you. Get them excited.
Right.
Yeah. The when you do interview, the ball should not. No, it's you need to turn it from them controlling you, becoming you controlling, but excite them. Talk about, listen to the person, what their interest, and talk about subject that will interest them, not subject that interest you.
That's right. Yeah.
I don't care about what your interest. The interviewer, I don't care about your interest. They care about how can they get, from their side, what can they get? So you need to excite the people.
Mm.
Get them excited. This is the knowledge that this is the thing that looking for. Get them really excited.
Mm.
Yeah. If the interview is very boring, one way, very boring, that's you're in the mercy of them, and you have a thousand other people that will be as qualified. How are you going to differentiate yourself? How are you going to be differentiate yourself? You differentiate it from your geek side and then from your speak side, your communication skill. So build both sides. So I put my tagline in my LinkedIn to remind every young people. When I was at Wells Fargo, every year we hire about 100 new graduate, people with PhD and master. And we put them into cohort, into training and rotation. the first day of orientation is always my speech.
Okay.
My speech is about being a quant. Okay. And the last slide is be a geek who can speak. Yeah. Meaning you have to keep get deeper and deeper in your technical capability, but also
Able
your
to.
ability to influence people.
Right.
Right. That will differentiate you.
Yeah, those are some great advice. I mean, yeah, definitely. Communication is very important, I believe. Just knowing technical concept won't help. I mean, communicating to the stakeholders or communicating to the colleagues is equally important, I believe. So, yeah, I mean, great.
Very important, and you need to practice every single time. If you think about it, yeah. My and my daughter make fun of me all the time because my English is terrible. Okay, I speak English with Japanese accent. People know from Indonesia, oh, you're from Central Java. Okay, because of my heavy Japanese accent. Okay, so my English is terrible, but that should not become your handicap to
Right.
be an effective communicator. Okay, that you should keep learning and use it all the time. Practice every opportunity to have conversation with your colleague and all those things. I'm being intentional. Okay, I am not just talking for the sake of talking. I am practicing
Mhm.
every interaction with other people. Yeah. How can I influence these people? I am going to practice. If you have to deal with very difficult people, make it as a project. Okay. At work, some people are very difficult to deal with. Okay. This is going to be fun. I'm going to use it to practice.
That's right.
Yeah. If because you practice, then become instinct,
Mm.
right? Become instinct.
Yeah.
So use every opportunity to practice on the speak side.
Sure, sure, Dr. Eggers. Those were some great advice, and I really, I was just taking, a bunch of notes when you were speaking because I feel like, so much to learn from you, and of course, you are a thought leader in the space too. So definitely, thank you so much for giving me your time, and thank you so much for sharing
Yeah,
your journey.
thank you. Hopefully, it's useful
Yeah,
for people. Okay,
yeah, for sure.
and thank you. This is fun. This is fun.
Thank you so
Thank
much.
you, Ella.
Yeah,
Thank you, Mehul. This is really fun, and hopefully your audience will get benefit from this.
sure. Thank you so much.
Okay, so you close it with be a geek who can speak, right?
Yeah.
We need to convert everybody to become a geek who can speak.
For sure, for sure. That's the aim. That's the aim with this podcasting.
Yes,
Thank you. Thank you so
very
much.
good, very good.